There it goes. Today we're going to be solving rational equations. These first two examples should be pretty easy. All we're going to do is cross multiply here. So we are going to multiply 2 times x minus 15 and 4 times 3x minus 5. So cross multiply and distribute. So 2 times x is 2x. 2 times negative 15, negative 30. Distribute the 4. 4 times 3. And 4 times negative 5. And then from here, all I have to do is solve for x. So I'm going to move the 2x. So I get 10x minus 20.
Whoops.
And then I'm going to add 20. Add 20. So negative 10 equals 10x. Yeah. Divide by 10. And x equals negative 1. What's today's date? 28th? 30th?
30th. Thank you.
All right. Let's do number 2. So we're going to cross multiply. We're going to do 5 times x minus 7 equals 3 times x minus 3. Distribute the 5. 5x minus 35. Distribute the 3. 3x minus 9. Move the x's to one side, so I'm going to minus 3x. I get 2x minus 35. No, it doesn't matter. You can move the 5x and you'll still get the same answer. So it doesn't matter which way you move. Add 35. Add 35. So 2x equals 26. Divide by 2. And so x equals 13. All right, so are there any questions on those first two examples? Yeah. Go to B. So we're still solving rational equations. We just have lots of fractions now in my equation. All right, so instead of just having one on one side, one on the other, we've got lots of them. Yep. And so we're going to do something called the least common denominator strategy, which means that I want to get everything, all of my fractions, all 3 of these, to have the same denominator. So, looking at this denominator, what can I turn them all into? 3x. So, I don't need to multiply this one by anything. What do I need to multiply this fraction by? 3. So, I'm going to multiply by 3 on the top and the bottom. I need to multiply this fraction by? X on the top and the bottom. If all of your denominators are the same in the whole equation, 3x, 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 you can cross them out. So if all your denominators are the same, we're going to cross through them. So left with negative 7 plus, what is 3 times 4? 12 equals x. And negative 7 plus 12, 5 equals x. Okay, drop down to number 5. What am I going to turn all of these denominators into? 4x. So what do I need to multiply this one by? 4. Do I need to multiply that one?
No.
What about that one?
Yeah, by x.
By x. So all of my denominators are 4x now. So I can cross through them. 4 times 7? 28. So 28 minus 1 equals 3x. And what is 28 minus 1? 27 equals 3x. Divide by 3. So 9 equals x. Alright. Are we all good on those two? Go number 4. So number 4 is a little different. Something happens. First of all, some of these are not in fraction form, which might confuse you. So if I were to put them in fractions, what would the denominator be? A 1. So what do I want to make this denominator? I want them all to be what? X. So I need to multiply this fraction. Girls in the back. Shh. I need to multiply this fraction by what? By x. By x. I don't need to multiply this one, but this one by x. And so now all my denominators are x. So I can cross through them. Very good. Yes. So x times x is x squared minus 6 equals negative 5x. Alright, so I have an x squared. So it's a quadratic. So you need to think back to when we did quadratics and we did all of these fun ways of solving quadratics. There's one way that's probably the fastest and the easiest. You remember what it is? Yeah, make it equal to 0, and then what do I do? Yeah, the x method, factor. So we are going to add 5x.
Wait, where? What's this method called again?
Factoring. X squared plus 5x minus 6 equals 0. And now I'm going to factor it using the x method. So what multiplies to give me negative 6 adds to give me 5.
I mean, yeah, negative 1 and 6.
Yeah, positive 6, negative 1. So x plus 6, x minus 1. Yes, so I'll have two answers as my solution, which are what?
Negative 6 and 1.
Good, negative 6, positive 1. All right, let's look at number 6. What is my denominator going to be on number 6? 2x, right? So what do I need to multiply this one by? What do I need to multiply that one by?
2.
And what do I need to multiply this one by?
2x.
So now if you look at all your denominators, they are all 2x. So I can cross through them. So x times x
X squared.
plus 6 times 2
12.
and equals 4 times 2x.
8x.
Good. Once again, we have a quadratic, so we're going to move everything to one side. And it's usually best to keep your x squared positive. All right, so if you can, keep the x squared positive. And what are two numbers that multiply to give me 12, add to give me negative 8?
Negative 6, negative 2.
Negative 6, negative 2. And for my solutions,
6 and 2.
okay. Because of time constraints in this class that we're running towards the end of the year, the back, all these word problems, are going to be bonus questions. So you're welcome. So we're going to let these be bonus on the test and stuff, and even on the practice. If you don't do them, you don't have to. If you want to do them for practice, you can. I'm going to do number 7 and 8, and then I will let you decide if you want to do them or not. But on the test, they'll be bonus. Okay? You're going to see mainly just a problem like number 7. You're going to see a problem like number 8. So 7 deals with, it's like a work problem. It says, Michael can paint a fence in 8 hours. Jack can do it in 4 hours. How long will it take them to do the job together? And so I have how fast Michael can do it. I have how fast Jack can do it. And I want to know how fast can they do it together. So since they are going to be working together, I am going to be adding stuff up. Because they're working together, right? And I have how fast Michael can do it. I have how fast Jack can do it. Now I'm saying how fast. Fast is a rate. Does that make sense? I want to know the speed that they can paint these fences. So I'm not going to just put 8 into our times. You'll see. Hold on. So I want a rate. So Michael can paint one fence in 8 hours. Does that make sense? So it's a rate. He can do one fence in 8 hours. And so Jack can do one fence in 4 hours. And for them doing it together, I want to know, they can do one fence in how many hours? That's what I'm trying to figure out. So I'm going to put an X here because I don't know how many hours it'll take them to do it together. Does that make sense? All right, so fast, it's a rate. How fast can they do it? It's a rate. They can do one fence in how many hours? All right, so now it's a regular rational expression. What am I going to make all my denominators? 8x. So what do I need to multiply this one by? X. What do I need to multiply this one by? And what do I need to multiply this one by? So they all go away. X plus 2x equals 8x. Or just 8, sorry.
What is the little box?
I don't like the box. I'm the box, so ignore the box. I tried to figure it out and I just confused myself. There's got to be some kind of method, but I don't know what it is. All right, so x plus 2x is 3x equals 8. And then divide by 3, divide by 3. So they can do one fence in 8/3 of an hour. Right, not that bad?
Wait. 3x is 8?
Mm-hmm. All right, last one. Number 8.
There's gonna be more than 2.5 hours.
All right, number 8. Sarah can row 4 miles upstream on a river in the same time it takes her to row 6 miles downstream. Her rate of rowing in still water is 2 miles per hour. Find the speed of the river current. So this one is a little confusing. So I'm not adding two things together because I just have Sarah and I know stuff about her going upstream and I know stuff about her going downstream. Does that make sense? Yep. So I'm going to set some things I know about her going upstream equal to some things I know about her going downstream. But I need to figure out what is equal when she goes upstream and downstream. It's not the distance because upstream she's going 4, downstream she's going 6, right? So what is equal? Time. Very good. The time is the same. I know, it's really annoying. The time is the same. And so if you think back to physics, time is the distance over speed.
You can't say think back.
Distance over.
Think in the future, you mean?
Think to physics. Y'all have done that before, right? Distance over whatever.
Time equals distance over.
All right, well, I'm telling you, time is distance over speed, right? And I know that these two things are equal.
Mr. V, that's the only.
So what is the distance of her going upstream?
4 miles.
4. What is the distance her going downstream? 6. So now I just need the speed. And I don't know if you remember when we did our problems when we had like the boat and the current, right? All right, so it's going to have that kind of mindset. If you have this current, right? and the current's going this way. If she is going upstream, what am I going to do with the current and her speed?
Negative and positive.
Right, they're going to subtract. And so when she's going upstream, I'm going to say the river current is x. That's what we're trying to find. Right, her speed is 2. So I'm going to subtract 2 minus x.
So this is why these things bonus is actually good.
Because they're going different directions, so we're going to subtract them. Right, the current's going against her. So the current's going to be negative.
Well, it's gonna be 2 plus X.
Right, and so when she's going downstream, they're going the same direction. The current's helping her. We're going to add it, 2 plus x. And then now we can solve. So we're going to cross multiply. 4 times 2 plus x equals 6 times 2 minus x. 8 plus 4x. 12 minus 6x. They're doing like lawn out there, right? Is that what that is?
No, it's your window.
It's the air, like, going through like a crack in the window somewhere.
What?
Wow, you're supposed to be like,
All right, so add 6x, add 6x. So I have 8 plus 10x, and then minus 8, minus 8. 10x equals 4. Divide by 10, divide by 10. So 2/5 miles per hour.
that's
Huge.